Hi, everyone. My name is Paul Haefele, and I'm the Managing Director of Technology. I run technology and operations at Deep Value. And I'm here to talk about how we've used Hadoop to enable us to do simulations for high-frequency trading. So I wanted to just kind of give you an overview of what I'm going to talk about. First, I'm going to talk about who we are, and then discuss about what we do. Have a little brief discussion about what is high-frequency trading, and what kind of technology have we built to enable us to do some high-frequency trading, and what that technology looks like. And then I'm going to talk about how we use Hadoop along with our trading technology. And I'm going to try and focus mainly on what we've built at a top level to give you some vocabulary and some appreciation of what a trading system looks like and what that ecology looks like. And then kind of lessons I've learned as we've gone along building this, both from building the trading technology itself as well as building what we learned when we implemented Hadoop. I then want to talk about some next steps and what we're thinking. We're thinking maybe we're going to try and take this and see if we can open source it, maybe via the Apache framework, and I'll discuss that a little bit. Okay. So who's Deep Value? We like to think of ourselves as an unnecessarily well-kept secret, but we were started in 2006, and essentially what we try and do is our initial founding was to provide high-performance algorithms where we get paid on a pay-for-performance basis. And essentially what this is that we wanted to be, as our customers save money by having better execution tactics, we wanted to take some percentage of that saving that we'd saved them, and we both have then skin in the game to make sure that we provide better execution quality. And what is an execution algorithm? Well, at the highest level, an execution algorithm takes a very large customer order. So a mutual fund might decide they want to buy IBM or Apple, and they don't go and buy a few hundred shares of Apple. They'll buy 100,000 shares of Apple at a go. Okay? And if you're going to do that, you have to have some strategy to go about executing that order. You can't do it all right now. And so it becomes taking that order and spreading it through time. Okay? And as soon as you've got to do that, now you've got to make a decision at every point in time is, do I trade now or do I wait a little bit? Okay? And so we have an engine that helps us do that, and that's what we've been trying to build, is execution algorithms. So we routinely trade between 0.5% and 1% of the US stock market. Our highest date in 2012, we traded 4% of the US stock market on one day. This is on a double counted basis because every trade has a buyer and a seller, so there's actually 200% orders, but it's still quite a reasonable number for what is not a very large company. So our main client is the New York Stock Exchange. We're an exchange-sponsored algorithmic provider, and we have 45 people. Primarily, our development and research is done out of Chennai and Bangalore in India. We have about 4 people stateside. So what do we do? So we utilize sophisticated math and statistics to try and see patterns in the data to come up with ideas about how to trade. And so that a lot of ideas we come up with are of necessity bad ideas. Okay? And so what you want to try and do is then try and simulate those ideas to see which ones of those actually might work or not work. So simulation is a key part of taking any strategy and trying to work out what it works, whether it works or not. Simulation is typically what it is taking the algorithm that you have, making some changes to it, and then going back and running that for several, maybe 100 days in the past, and trying to say, if we'd use this new type of, this new algorithm that we've just developed, how would that work? Would that have given us better performance in the past versus the one we used or not? And so we have we have a problem where we're trying to, it's a kind of embarrassingly parallelizable problem, which I'll get to in a little bit, and why we chose Hadoop. So our core business is providing these algorithms or these tools for execution to mutual funds. And just 2 things we believe in. I think we certainly believe those people who can harness the most compute resources are going to win in this game. So for us, we really wanted to try and see how can we do that. And all compute resources now are grids of machines. And so it led us pretty directly to using Hadoop because it's really the only game in town. So I want to talk a little bit about what high-frequency trading is and how we see it. Okay? So essentially for us, high-frequency trading is looking at everything that's going on in the market. So all the markets like the NYSE and the NASDAQ and all the various exchanges, they will publish to a multicast feed every single change that happens. So every order that someone puts in the market, every cancellation of the order, every trade that occurs, they will publish that in real time through multicast over various financial intranets. And you can listen to those, and if you're a high-frequency trader, you're listening to every single one of those, and you're making some decision about what to do next. So we listen to all that. So the high-frequency traders often are also trying to capture rebates. So the way the exchanges are organized is that if you place orders at an exchange and you let it rest there, so what you do is you're saying you're actually providing liquidity, it's called, and you're saying, I have some shares to sell, would anybody like to buy these? By doing that action, the exchanges themselves will pay you. Okay? So what they're trying to do is they're trying to attract order flow onto the exchange. And so if I put my orders out there and someone decides to buy them, they will give me 27 cents for every 100 shares that I do. And so that's quite attractive, really, in some ways. And so this is what a lot of high-frequency traders are trying to do, is trying to get those rebates, because that's a large percentage of how they can make some money. And so, for example, Citibank was a favorite stock in doing this in. It was when it was a $3 stock, which they changed this about 6 months ago. But prior to that, Citibank had the highest volume of any stock by a very long way. And the reason was it was a $3 stock on a very, very expensive company. Its market cap was very large. And so even a 1 penny move in that meant that Citibank was now it was going to be hundreds of millions of dollars worth of company valuation change. And so it didn't really move very much because they had this 1 penny spread. And so people would sit on both sides of that all day making rebates. And so it was high-frequency traders were making a lot of money by just providing liquidity on something as simple as Citibank. They've subsequently changed they did a split, so it's not like that anymore. High-frequency traders, also one of the things they're doing is doing some what we call sniffing out of orders. So they'll place orders on the exchange to try and see what other people are doing. So if someone has a very large order and you're trying to trade it, if you're doing that in some dumb way, they will try and hit you and try and see how the other side replenishes. So they're trying to sniff each other out, and so there's quite a lot of that going on. Okay, but it's kind of turned into a speed game for some number of people. Okay, and if you go to a conference where they discuss high-frequency trading, people are talking about how can we go faster. So a very big part of what people have been doing is taking complex code that looks at the market data and burning it into FPGA boards. Okay, so a lot of these guys are just trading totally on an FPGA board. People are very concerned about how long the wire is at MAWA, which is in New Jersey. It's where the New York Stock Exchange has all their servers. One of the key things they had was that no one is advantaged, and because the NYSE has some specific rack over here where they trade. If you happen to be physically closer to that or further away, there would be a difference. So what they've done is they've made all the Ethernet cables the same length, and they've coiled the ones that happen to be closer so that no one even has a slightly longer cable. Okay, just insane. But they're talking about the latest thing is now the futures trade in Chicago and the stocks trade in New York, and so there's this. The futures are essentially what do we think the price of a certain stock is going to be in 3 months' time, and the stocks themselves are the actual what it is now. And so these two obviously have some bearing on each other based on the interest rate, and so there's a big arbitrage going on. If the stock goes up a penny, well, surely the future should probably go up a penny as well. And so if there's some latency in there and you knew ahead of someone else what the stock was doing, you could then buy or sell the future. But because they're in two different cities, it's been a kind of how fast you get between them is kind of a big deal. And so they've decided that, first of all, they laid a direct cable from New York to Chicago rather than going up and following the railway lines. And that was quite fancy. But now they've decided that fiber optic cable is not fast enough. okay, that you can go faster than fiber optic cable. So they're now putting a whole bunch of microwave towers that from New York to Chicago to shave off, tens of microseconds. Because if you are tens of microseconds ahead of the next guy, it means you are at the front of the queue, you trade, he doesn't, and you can just make money. So it's become like an arms race. We are not in this arms race. This is companies like GetGo and so on. So we have decided that, this is probably a race to the bottom to some extent, although they make a lot of money doing this. But we are trying to use smarts, okay? Trying to use, and Hadoop is part of that, okay? To try and do smarter things with the data to try and get ahead. Okay. So I wanted to talk a little bit about what trading systems are. I kind of thought that, we're in San Jose and people don't know too much about trading systems or what makes up a trading system. So I thought we built our own, okay? Mainly because we didn't feel like the players in the market had the technology. I didn't like how they built it. It wasn't, for various different reasons. So we built our own. So I thought I'd talk a little bit about that, okay? So the first things, they're all called order management systems or execution management systems. There was some difference between these things at one point, but this is what they are. So it's an order management system. And what it does is it takes in market data, which is market data is what the market looks like. All the orders that anyone have placed in the market where they're willing to trade at a certain price. It's called the order book. And this order management system will take in the flow of all that market data. And then what it needs to do is it needs to look at that market data, it needs to make some decisions, it needs to maybe wait some amount of time, it needs to do some calculations, and then it needs to send orders out to the market. Okay? And this is done via a protocol called FIX. It's been around for some amount of time. They're on FIX version 5 now. And it's a name value protocol. It defines a message. It actually also defines a transport mechanism, which makes it kind of a little ugly. But essentially, it's a name value paired message where you would say the symbol equals IBM, and the limit price is 35.1, and the counterparty is this. So it's a name value pair message, and it constructs these messages and sends those out to the markets. The markets all understand the FIX protocol and then trade. So you have to have a FIX engine. There are some open source FIX engines, and we've used one called QuickFixJ, and so we built it on top of that. Okay. And then it receives fills coming back again. Okay, so these are trades. Okay, so when you send an order out to the market, you might not get executed immediately. Someone else sends you a fill coming back, so you have to process those, and you need to have logs coming out of it. So what is your system doing? So this is really what our trading system primarily does at the highest level. Okay, this is what it does in a little bit more detail. We use Terracotta, okay, as a shared memory platform to help us manage our cluster. We built it as a cluster of containers. We have these two FIX engines you can see on the left and the right, the inbound and the outbound FIX servers. We have what we call work containers. This is where the calculations all happen. Okay, and we built a work framework to let us. We got the idea from the JMS type containers, and we have market data coming in. We write everything down to a MySQL database, and to do that we had to do batching because you can't do inserts fast enough. So we just wrote something called the scribe server. So this is what our system looks like, and it was quite instructive to build this. When we first built it, it could process 1 order a second. It wasn't very fast. I believed the hype about Terracotta, and you can just take your JVM and put it in there and it'll all magically work in a cluster. It wasn't true. But so I wanted to talk some of the things we learned about building such a system. I thought just quickly, so I know this is not Hadoop, but if we're going to show this, I might as well tell you a couple things. So first of all, if you're going to build a cluster, you've got to worry about cluster-wide locks. It's your only problem, okay? Really, it's like, how often are you focusing on it? And you really got to focus it in your design, okay? There's no point having anyone taking a cluster-wide lock in anything that any amount of speed that you need, okay? It's not going to work. So you can take cluster-wide locks, just you've got to be very careful how often you're taking them. So the other things we learned was that you should really, if you want to make something high speed that also needs to fail over, you should really focus on like making the high speed path fast and not worry about it failing over, okay? If you're going to have some fancy failover mechanism, like build, that can be quite slow. That's not really a problem because that's not happening 99.999% of the time. Your system should not be failing, right? So don't put any kind of failure assumptions in the kind of the fast path of how you're processing messages. Okay? And so we found that doing a hybrid message passing and centralized control cluster worked out really well for us. Okay? And I'm happy to talk about that more if anyone's interested, but this is a Hadoop conference, so I won't go into more. Okay, so what questions were we trying to solve, and why do we need Hadoop? Well, one question is we had a problem was, well, what are algorithms actually doing? Okay, so this is a big problem because it's doing lots of things. It's getting lots and lots and lots of updates, and we have some specs saying the algorithm should do A, B, C, D, but we don't know if it's actually doing that. Okay, and there's lots of complex feedback loops that happen with the exchange. You can place an order, and then you can have another agent saying, well, take the top of the book and maybe place an order just ahead of who everyone else is because you want to start trading. So you kind of offer a stock to be sell at a higher price. And so you step ahead of it, but then your other guy says, oh, look, I should catch up and I should be at the top. So he moves up, and the other guy says, oh, I should be one ahead, and he moves up. And so you have these agents who are all trying to work together, which is how our system has been written. It's a bunch of trading agents who interact. But they have this complex feedback loop that can happen with the market. And if you don't look at very carefully what you're doing, you might not notice that. Okay? And so we had this problem of how to test it, testing against intentions. So this is the one thing we had to try and solve. And the second thing was, how can we do better next time? We have this algorithm that traded today, and we want to see, can we improve it? So we have to do back testing, and part of that was to kind of introduce our trading system into our research process. The other problem we had was we just had a lot of logs coming out, and we had no way to manage those logs. So we had no way to put them. We were filling up NASs very, very quickly. I felt bad about throwing away logs because there's obviously valuable information in them, but I didn't know what to do with them. Okay. All right. So before I jump into more of what we built with Hadoop, okay, I wanted to just talk about our research process, okay, or how we go about kind of coming up with algorithms, because half our company is researchers. They use R and various statistical tools, primarily R, to kind of come up with ideas. And then the other half of our company is are programmers. So they're using Java. Our system's a Java system. And they are kind of coding up various specs that people have written. So I wanted to kind of explain about our research process just a little bit. So, first of all, our researchers, they look at raw market data. So they kind of gather in all the quotes, and they use R to try and understand and try and kind of answer questions out of that raw market data to try and see whether or not certain patterns might hold that they think is true. Okay, and so they started using the R project, okay, because we use that, and R does have a Hadoop version. I think there was a discussion yesterday that there are packages, RMR I think is one, that let you run R in the cluster. So we've been able to do that. Yes. All right. So, but one of the problems is that we wanted to also, so there's this. They make these kind of calculations that they want, and they will then write in R some simple algorithm that will go ahead and try and mimic the trading they want to do. But one of the problems is we can't take that R and run it in production. We don't want to run R code in a production environment where you're actually trading with the market. So writing R code, okay, that they say, this makes money if I run it in my simulation. Then we have our developers take the spec that gets written from that and code it up in Java. And then we run that Java in production. And if the R code says we should get this kind of performance, and the Java code gets run in production and it's not getting that performance, well, we have a big problem because now these are two different code bases. There could be lots of kind of differences between these two things that are going on. So really, what we wanted to do was have our researchers write or make changes to the production Java code. And so that now if there's some difference, we're only looking at 20 lines of code that they've changed, not this giant difference between R and Java. So we really were trying to solve this problem too, okay? And Hadoop actually helped us solve this problem, okay? And the other thing about that is that if the researchers have made changes to code, in the production code itself. You can just take that production code and put in it. You can just take it and then run it in production because it's the same code base. And so that was meant you can speed up things. Okay. So what we decided to do was to take the first thing I showed you, which we call Chloe for the clustered order engine. Okay. And we decided to take that and run that as a map job. Okay. So if we go back again, we had fixed servers, we had work containers, and we had market data. And we decided to just take the work container, which is like the thing that runs the logic, and we made that essentially a map process. Okay. And then we drive orders in from within that map process. We work out what orders do we want to try and trade, or what overall portfolio did we want to trade. We drive that into the work container. We take the historically recorded market data and we drive that into the work container. Let me just go back to this picture, actually, it might help. Okay. So in the middle we have the work containers, okay, and this is what run the logic. So we stripped off the inbound fixed server, we stripped off the outbound fixed server, we stripped off the market feed server, and, well, we threw away the database too because we didn't need that. But and what we said is, we said, okay, this is the portfolio of types of things you want to trade, the universe of stocks, that we kind of predefined up front. We wrote a market simulator that says, if I place this order in the market, what's the likelihood it's going to get filled? Okay? And it's this that is quite tricky to write, the market simulator, because if you could write a perfect market simulator, you could essentially make money all day. Okay? But you can do a pretty reasonable job. I mean, if you can do a pretty reasonable job of writing a market simulator. So we wrote that, and then we took from the feed server, which is the feed server is providing you the quotes and trades of what's going on in the market. With that, we just took recorded files from the past and we just played those through this way. Okay? And so then what we could do in our Hadoop cluster is say, okay, we want to run these 500 symbols over the last 1 year, the last 250 days, and every one of those symbol days becomes a map job. Okay. All right. So then what you can do is we run your system in sped up time, and so what you do is you just keep moving the clock forward very, very quickly, so you can run it quite fast. So we can do a whole day, I think even the biggest symbol in like 70 seconds. And then you take all the results and what happens, and you store that back into Hadoop again. Because one of the problems with doing this, if you run 500 symbols over the last year, it's like running production all over again. Okay? And even handling our production logs was quite difficult. So now we have even a bigger problem, we're running production again and again. So that has to all go also back into Hadoop again. And you have to then analyze it. Okay? So the market, so the market simulation outputs fills, it outputs what we think we would have traded, and then we run cascading on that fill data to say, well, how much, what day, what symbol lost the most money, what symbol was the most profitable, these kinds of questions to kind of analyze that. Okay. And we like cascading a lot. It was very, very helpful to help us do that kind of analysis. So this is a slide that overviews what we built in Hadoop a little bit. Okay. So we have 3 environments. We have the local quant desktop. Okay, and the local quant desktop is our developer's machine. Okay, it's actually a researcher's machine typically. So using Eclipse was kind of a new thing. They really were much happier using VI and some very simple tools, but we really wanted them to use the best tools. So this is the one environment. And then the pink environment is a simulation cluster. Okay, so this is either an EC2 cluster, or we built our own EC2 cluster, and then we now have our own 50 machine cluster that we built because EC2 is costing us too much money. And then we have the production infrastructure, where the production infrastructure is the thing that's really wired up to the market, the thing that's really wired up to the market data and actually trades. So it's these 3 environments. And they all, on the quant desktop, they run the little blue squares, okay, that say if the bid is less than the ask, place the order. This is the trading logic, okay? And they code that up in Java. And what they would do is, on their local machine, they would code up this logic. Okay? And often they're making quite small changes to logic that's already there. They're adding a new signal or something along those lines. And they would run that inside the clustered order engine with the simulator. And so what we did was on that desktop, they run a command saying, give me the latest code base. And it downloads Hadoop, it downloads the Chloe code, it downloads all the code and everything they need, not the data, but all the code they need onto their local desktop. And then they can debug it. Okay? They can debug what the code does. They can run one symbol for one day and then see what it does. And it draws the market data, historic market data down into the local quant desktop. This is all stored in Hadoop. It says big data just because this is a sales presentation we make to people, but it's just really all Hadoop, okay? And it draws that historical market data down. And then as it's trading, and once it's finished trading, it writes all its data down into this orange cylinder, which is also just in Hadoop. And it's all the emissions. Emissions are log files, okay, just a structured debug. It writes all the run details, how many servers, how long it took, this kind of stuff. It runs all the what we call TCA, which is transaction cost analysis. How much money did it make, averages, and kind of more, how the transactions did. And we also write all the code and all the configuration. We take all the jar files that you just ran and we shove them into the database, so you can know what code ran on what day. Okay? And so you do that in your quant desktop. They get it working, they debug it, and if they like that, then what they do is they say, okay, fine, now let's run it on the cluster. And with just one command, they can then say, okay, take this jar, run it on the cluster, and now I want to run it for 100 days, 250 symbols. So they can then just run it on the cluster, and that does the same thing. It reads in the market data, writes out the analysis. And if you like that, then what you can do is you can say, okay, take this jar and now run it in production. Okay, we have a bit more process around that, clearly, because you don't want to just run any old thing in production. But essentially, it's exactly the same piece of code. And then we've written various web screens that allow us to then look at various different runs, one simulation run against another simulation run, drill down and see which symbols maybe made money or lost money, so you can kind of understand what the trading is exactly doing. Okay? And so this is how our Hadoop environment looks. Okay? So what did we learn about, what did we learn by doing this? Okay? So I would say the first thing we ran into is our EC2 costs mounted quite rapidly. I mean, EC2 was great, okay, because it did help us get going. I think, we would not have started buying, well, we were running 1,000 machine clusters at one point, okay? We would not have built a 1,000 machine thing without, kind of learning first that it worked. So it was great from that point of view, okay? So I think it's useful to have a hybrid plan, and we did have a hybrid plan where we were planning to run on our own cluster or EC2, but we can do either with just changing a command line. So in the end, we ended up building our own 50-node cluster. I wrote a blog entry. It's on deepvalue.net if you're interested, but we worked out that it was essentially about 4 times more expensive to run it on EC2 compared to running it our own cluster. But I think that really does depend on exactly how often you run your cluster, how utilized it is, how spiky it is, and so on. So that was just our results in any event. So what else did we learn? Some of these things have been mentioned elsewhere, but you've got to be careful of smaller files. Okay, we ended up the way the name node works. If you have lots of files, it keeps all the pointers to all the files in memory on every name node. So if you have lots and lots of files, your name nodes start running out of memory. If your name nodes start running out of memory, your cluster crashes. Okay, we not only had like tiny files, they were just not giantly large files. Okay, they were so we had a problem with that, and so the way we solved that was putting stuff into HBase, and so we used HBase to store all our market data rather than storing it in HDFS files. Okay, so that was pretty useful. The other thing that we learned, and we're quite excited to hear about Yarn because of this, is that if you have different tasks in the same cluster, they don't really play well together at all. So we only use two different types of map jobs. We have map jobs that are from R. So we run R in a map job and then run R code. And then we run Java, which is the Chloe system that runs in the map job. Our Chloe jobs need 2 gigabytes of RAM, and our R jobs need 6 gigabytes of RAM, and just the small difference between the two means that our cluster, we actually had to build 2 clusters because obviously Hadoop doesn't know that these two things have different memory requirements. It puts a whole bunch of 6 GB RAM requirements on a machine without enough RAM, and that just doesn't work well. Okay? So we're quite excited by Yarn, and as soon as it's in beta, I think we'll try and grab that and start using it. So other lessons we've learned, well, I think a key thing is to make the development machines turnkey. Okay? So we had researchers. Initially, we gave them a very long list of like what you've got to do to get your machine working as a developer, and it was download Hadoop, make this change in Eclipse. I mean, it was like a 10-page document that someone had to follow step by step, and if they made a mistake, it didn't work, and it didn't work well. So we just kind of constantly went at kind of scripting it, writing bash scripts so that someone could go onto their machine, and now a researcher going to the machine, they can type install Chloe, and it just does the whole thing for them. Okay, it creates actually a brand new user, and it then creates a clean environment for that user. And so we just SU to different users if you want to have different installs, and that was helpful. And it lets you control your dev environment, which I think is an important thing. Okay. So cascading was very useful. I really felt it sat at exactly the right level between SQL is not complex enough to allow us to do the kinds of analysis we wanted. Certainly, I don't want to be everyone writing MapReduce jobs. That would have just been too complicated. But cascading really sits at a great point where you can think about it in terms of pipes and filters, and an easy way to think about the analysis you want to do, and then implement it. So that was very good. Okay, and that I think we really had to spend a lot of time thinking about how to configure our cluster. How much memory does each mapper get? How many threads? How many cores are on the chip? And so on. So I think the more we focused on this, the better the cluster ended up performing. Okay. So I want to just talk about next steps. Okay. So we are thinking of open sourcing this via an Apache license. Okay. That essentially. We think that there are other open source trading systems, okay, out there, but none of them are they more for like either the individual investor who wants to try and run something. I don't know any like hedge fund or any other serious person who's using those types of things. But this is a serious piece of technology. We trade hundreds of millions of shares on it every single day. Like we're a core part of the NYSE infrastructure, so we're on their infrastructure calls every day. So it's a very solid and kind of a robust piece of software. And so I think we could convince a large portion of the trading community to use this. We're hoping. And we wanted to bring some sanity to the traditional execution technology space. It's populated by we talk to various traders, and they're not very happy with what a lot of the execution engines that are out there right now that are, honestly quite expensive as well. So, we think that this could be kind of something that could shake up this industry a little bit. So, we're quite excited to look at that. We're trying to find someone or some set of people to be a founding team to kind of take this out and push it out to the market. I think you'd have to have some structure around it. So we're looking for people to do that. So if that's of interest to anyone, please come talk to me. Okay, and but it's been very exciting. I think Hadoop is, we really like it. It's been very, very helpful, and it's certainly revolutionized the way we go about doing research at Deep Value. All right, so if anyone has any questions, there's a couple of mics if anyone wants to ask anything.
So, just related to this slide, what advantage do you see in open sourcing this to you as a company?
Yeah, so I think, no one wants to have vendor lock-in. So I think that is the one thing that you would allow people to get away from. I think the other thing is that, everyone likes to do simulation. I mean, every trader you go and talk to, you say, is simulation important? They will say simulation is important, okay? And none of the current execution vendors allow you to do simulation on a cluster, okay? It's not something that people let you do simulation, but not on a cluster. And I think doing simulation on a cluster means you brought to bear a much larger piece of compute platform. And the more compute power you can throw at a problem, I think the better you can do simulation, the more sophisticated your algorithm can be. So I think that is a key advantage. Yeah, and I think I think we have a good piece of trading technology, and so either we go out there and try and sell it like everyone else, or we try and do something a little bit more disruptive. And so we're quite interested in doing that. Any other questions?
Yeah, I was curious
Sure.
what Hadoop distribution you selected and if there was any reasoning behind it or just the first one you got.
Yeah.
And also for your performance enhancements and analysis, if it was just all trial and error or how you went about doing that.
Yeah. So, all right. So we use the Cloudera install, okay, and for actually no good reason, okay. And talking to people here, and I guess this is a Hortonworks thing. We might well change, okay. But we initially used the Apache version, and that was a bit of a disaster because it was just. It seemed just too confusing about the number of versions and whatever. So, there was no particular reason for selecting that one. In terms of performance tuning, I assume you mean performance of the Hadoop cluster, is that right?
When you're talking about cores.
Yeah, it actually was more about, we know what the map job is doing. We know that it's a single threaded core that's reading the data and running through time. So we knew each one is a single threaded process. We knew how many cores we had on the chip. And so we analyzed that. We know how much market data we're reading in, so we could kind of see how much memory was being used in the process. And so it was really just measuring and understanding what the map job itself was exactly doing. I mean, so I think it was more that we went about tuning it. Yeah, I would say that was primarily how we went about it. It was a trial and error a little bit, for sure. Yes.
How much is it concerned security in this platform?
Yeah.
Security.
Yeah. So security. So in finance, okay. For example, none of our installs, okay, or any of our machines are available on the web. You can't go and ping any production server, okay, on any port anywhere, okay, because we just don't want someone hacking in, okay. Our web page is hosted by someone else completely separate, okay. So and all when you send orders to the market or when you receive market data, that is all done on a network called Safety, which is a New York. Well, NYSE runs it, NYSE Euronext. They run that. It's a private intranet, and it's like the internet, but just obviously their own private thing. And they are very careful about how you get on there. They don't let anyone on there. They've only open certain ports and so on. So it's quite secure from that point of view. Okay. Internally, we don't worry too much about security. We're just one company. We only have a few clients, so we're not too concerned about keeping track. Well, we obviously keep our customers' data separate. Okay, but it's not. We're kind of secure from that point of view.
So, quick question for your production cluster, because lots of data streaming in.
Yes.
Time series data. How do you handle it in Hadoop?
Yeah, so we actually don't run Hadoop in production. Okay, so Hadoop is only used for doing the simulation environment.
Oh, for the historic data.
That's right.
Oh,
So
I see.
Yeah, that's all. Yeah. Hi.
I got in the process that you're basically outputting your desired fills that your algorithm would have produced, but did you actually have a feedback loop though, that you were actually simulating like an ensemble of agents that were each trying to do that like one up each other kind of thing, or was it that full simulation, or?
Yes, that's full simulation is what we're doing. Right. So the way we organized our trading algorithms is that any algorithm, let's say we're trying to match the average price of the day, okay, which is a very common algorithm. So what you will try and do is, you have someone who'll sit there passively trying to see if anyone wants to trade with you, but now you're starting to fall behind where you think you should be, okay? And so now you want to kind of get it more aggressive, and so what you might do is take the spread between the bid and the ask and kind of narrow it a little bit because you want to get a little bit more aggressive, but at some point in time you're so far behind, you've got to say, well, I've just got to pay someone whatever they're asking for the stock. I've just got to buy some now. Yeah.
In that simulation, are you actually pushing feedback data back into the data stream that's coming in?
Yeah. So actually,
how did you do that?
Yeah. So we can do that. Okay. And I think some part of our thinking about our next version of the simulation is going to be saying, okay, this trade occurred. Okay, change the stream. That does create some amount of problems, okay?
Yeah, so that's asking.
Yeah, because you get in with this feedback loop where, so you already pushed it really high and now the stock price has gone up, but now your market data doesn't look like anything like the historic market data looked like, okay?
But right now it's just a fixed data set coming in that you're
That's
basically
right.
reacting to.
That's right, yeah. It's made it simpler. And it's actually okay because we're passive most of the time, so we're not, it doesn't really matter that much. Yeah, it's a good question.
So I had a question about, you mentioned earlier you had an issue where people wanted to use R, but you wanted to use Java.
Yes.
I have a similar situation. It wasn't clear to me how you solved that problem. Are you just allowing, by pushing R into the simulation, you can allow analysts to first simulate in R and then in Java when they implement in Java to make sure that it's consistent, or did you actually do some kind of conversion from R so that you could run it in Chloe?
Yeah, so we don't run R in Chloe, okay? So I guess there's two kind of reasons we're using R, okay? We're using R to come up with like completely new trading algorithm. These things people do in R because, you know, it's much more kind of trying to understand exactly what's going on. But that's one type of thing that we're doing. The second thing is we're taking a trading algorithm that we're already running and we're trying to make small changes to that, okay? So previously we were kind of doing all that in R, but now we decided these smaller changes, where it's maybe 100 lines of code, a researcher can certainly make those types of changes, okay? And so it's that we've given them the Java code for, and then they can tweak and they can play and they can see what works and what doesn't work, because that they can do. And it's that's Chloe that they run on the cluster. So we've actually provided both of these things for them.
Just curious, what kind of parallelism you are exploiting when you do the 1,000 node cluster?
Yes.
Is it on each symbol going to each mapper, that kind of thing? So
Yes, so we have a concept of a name day, which is one symbol on one day. So all the symbols are, because of the way we trade, each symbol is separate. So you know, if you're trading IBM, it doesn't matter what Apple is doing. Okay, well, we don't look at that cross correlation. Some people do, but we don't look at it that way. Okay, and so there's that, and obviously one day is completely separate from the next day. This also actually is not always true. Okay, it's only the way we do it. Sometimes one day affects the next day, because if you buy 1,000 shares today, and you now need to simulate tomorrow, if you hold that a very large position overnight, that becomes a problem, okay? So if you were writing an algorithm that's trading 1,000 symbols where every day is dependent on the day before, you lose parallelism, okay? And so that does make those types of algorithms a little tougher to simulate. We have some ideas about how to go about that. You can certainly simulate different configurations, okay? But it's not, you're losing parallelism, and for us, it's not been such a problem because we do trade. We don't hold very large overnight positions, and execution algorithms you don't, and we don't trade stocks together. All right, thank you very much, and thanks very much.